Hi there, physics students. So when we left class today, this is the data that we had, and I told you to go home and make a graph, okay? Marvin even asked, do we average the data? And I said, no, I want to see all the data. Apparently, Excel, I didn't think this was going to be a problem, but I guess I was confused. Apparently, if you graph, well, let's see, what are we graphing here? I told you to graph X versus time, position versus time. And what that means is position is along the y-axis and time is along the x-axis. Y versus X. Okay, that's how it's read. So position versus time. All right, so we want time to be along the x-axis. And so when you graph multiple values along the x-axis, apparently it won't allow you to do that. You can graph multiple values along the y-axis, but only one value along the x. So that's on me. So what I'm going to do is I'm going to make this third column here be the average of these two data points here. Okay, so I'm going to go ahead and change that now. This is average time. The variable there is t, and then Alt-Enter or Option-Enter to go underneath it and put the units there for seconds. Okay, I'm going to do the same over here so we're ready for tomorrow. Okay. So now what we want to do is average our times. Average our times. I now want this to be left one. Okay. So we're going to average our times here. So some of you are going to grab your calculator, right, which we love, and you're going to type in, 0.2, and you're going to add in 0.36, and then you're going to divide that sum by 2, and you're going to go, oh, the average is 0.28, okay? And you're going to type in 0.28 there, and you're going to move on to the next one. Don't do that. Do not do that. If you have Excel, that is the best calculator you're ever going to have, okay? So I want you to do the calculation in Excel. So here's how to do it. All functions, all calculations begin with an equal sign, okay? So how can we average? Well, we can do it two ways. We can either do it the math way, like I did on the calculator here. We can use a parentheses, don't forget the parentheses, and we're going to take that number, and then we're going to add it to that number, and we're going to close the parentheses, and then we're going to divide it by 2, right? So that will take that sum, divide it by 2, and that's going to give us our average, which is exactly what we got on the calculator. Okay? But that's fine, but there's a much easier way, so I'm going to delete that. There's, Bill Gates had his minions plug into Excel a function. Oh, by the way, this is the only piece of software, really, the only piece of commercial software that Bill Gates wrote, by the way, Excel. But it's quite good. And now he has his team build it, right? He no longer programs. He's just the CEO. Okay, so we type equals, and so he had his minions, he had his people build this function called average. Okay? A-V-E-R-A-G-E, average. And a function, for those that know coding, means you have to have arguments, stuff that goes inside. And so here, the arguments need to be enclosed in parentheses. So if we open up our parentheses here, maybe I'm going to zoom in here so y'all can see it more clearly. Let's see, can I do that? Maybe not while I'm... Okay. So I'm going to type equals average. Okay. Open parenthesis, and now it's going to ask me for the numbers I want to average. So I can click on this number and press a comma and click on this number and press comma and keep going. Or if I had a whole bunch of numbers that I wanted to average, I could just highlight the row or the column of numbers and I can get that average. Okay. Close your parenthesis and hit enter. So now we can do it again. And then we highlight our data, and boom, pretty fast, right? Much faster than the calculator. Let me show you a trick. Okay, so once you get one equation done, and notice that my data is in a line like this, it's neatly set up. Okay, oh, come on. So I have my data in this nice data table. Okay, what I can do is I can click on this bottom right-hand corner. You see there's a little tiny square there, and my white arrow goes to a little tiny black arrow, like that. if I click on that corner, I can then drag it down, and that will copy that equation and paste it down, and it will move the references. It will move what's called the relative references. So, for example, if I double click here, I can see that it's taking the average of these numbers. If I hit enter, I can double click here, and I see the average of those numbers. I hit enter, and there it is. So it's calculating those averages for me. So that's why we use Excel. And then if we decide that, oh gosh, who did this data? Who is this? So if Lydia or Lucy decide, oh no, this is the wrong number, it needs to be, 0.22. How come I can't change it? 0.22 and hit enter. Watch what happens to my to the average. Boom, it changes. The average automatically changes. Again, this is why we use Excel. So I just Command Z did or Control Z did, and I put the numbers back to where they were. All right, so now we have our time data. All right, like so. So I'm going to delete this now because I want you to do the averages. Okay, so all right, boom. So I want you to calculate the average just like I showed you now. All right. So what I would recommend that you do is you either change it, on your own, or go online and download this fixed Excel spreadsheet. Okay, so I'm going to save that. It's already saved for us. Okay, now some people are having a hard time downloading this to their hard drive. So on a PC, it goes File and then Save As. Okay, save as a copy, and then I can save it to another folder. Okay, so I'm gonna, whatever, this is my Physics First shared folder. Maybe I save it right here. Okay, and now if I download and I go to the Physics First shared folder, there it is. It's 1:30 p.m. and this is the one that just downloaded here, the 1:30 p.m. one. This one downloaded. So now this is on my physical computer, and if I double click it, it opens up in the Word app. Okay, in the Word app. The Excel app. Okay, so here we are, and now I'm ready to make my data. And again, you guys will need to come in and average these times. See, it's not hard. It takes no time at all. Boom. So there, done. Okay, now I want to make a graph. What do we say? We want, on the y-axis, we want our position, and on the x-axis, we want time. So I'm going to teach you how to do this one more time. Write it down. This is the last time I'm going to show you how to make a graph. Put it in your notes. Okay, you're going to make tons of graphs this year. Write it down. So you have your data table. You have to know what it is you're graphing, what's along the y-axis and what's along the x-axis. Click away from the data. Go to Insert, and on a Mac, the insert is going to be up here in the menu, and for some reason Mac hides the menu. I don't know why, but they hide the menu. So you have to go up there and hover at the top, and then the menu drops down. Insert, and then Chart. Okay, and we're going to always choose this scatter graph. I'm going to take my chart, I'm going to move it out of the way. Okay, whenever I'm here, I should be on the Chart Design tab. Chart Design. At this point, I go to Select Data. Okay. On a PC, you're going to click on the letter or the button that says Add. On a Mac, there's going to be a little tiny plus here. A little tiny plus. Okay, Mac's very visual, so they don't want you to read the word add. They want you to click on the little icon that has the plus symbol, which means add. So we're going to add that series, so click on that. Now again, we're going to click on this button here, and we're going to go select the X values. What's along the X-axis? Think about it. What's along the X? Time. So we're going to click here. We're going to highlight our time values. Okay, and we're going to click off again. What's along our y-axis? Our y-axis is the position data. So we click that little button, click on the X data, click on that button again, and now we have click OK, and click OK, and here's our data. Now, I would have preferred it to have all, 12 data points on here, but it's okay. It's okay. Now, is this linear? Sort of, right? We got some data points here that don't look very linear. Which ones of these are bad? We don't know. We can't really tell. Okay? And again, this was a bad experiment, and I wanted to do it badly because I wanted you to see what bad data looks like. Okay? We did it on a very short track. We did it very rushed. The people's reaction time was a big part of the actual time. So we expect the data to be bad, and that's okay. We're going to do it again tomorrow, and y'all are going to help me make data that's much, much better. You're going to redesign the experiment. All right? And now at this point, you need to then fix the chart title, fix the axis titles, and you need to make a line here of best fit. So this is what I'm looking for. Again, the average time and the position. All right? So just be careful that this axis title here, or what you're graphing here on this x-axis, is the average time. Okay, and what you put along these axes should be what's in the header file in the data table. So average time, what's my variable t? What's my unit s? Okay, do the same for this. This is going to be our position, and then the chart title, don't forget, is y versus x of some object. What was our object? Okay, that's it for today. And then before you actually plot your, before you put on your trend line here and get what the slope of the line is, I want you to tell me, do you think that the car was moving with constant speed? Don't look at the data. Hide the data. Don't think about the data. Was the car moving with constant speed? And then I want you to estimate what that speed was. 1 meter per second, 2, 3, 4, 5. I'll give you a hint. Usain Bolt is the fastest human who's ever lived, and he runs the 100-meter dash in about 10 seconds. So he's running at about 10 meters per second. Okay? So the car was going slower than Usain Bolt. All right? So it's between 0 and 10. So what is that? What is that estimated speed? Just take a guess. It doesn't have to be correct, obviously. And that's going to be part of your hypothesis. How fast was the car moving? Okie doke. That's it for the day. And then get this done and come tomorrow with the graph made. All right.